I do have that delay at 30 seconds, not the 5 minutes, because we want to get that third pump started to prevent PLC 2 from taking over. Now pump 1 is going to stop, the third pump is going to stop at 92%, and then if you're running 2, it's going to go all the way down to 67. 67 is your minimum. This is protected at the VFD at 40 Hertz, which is 66.6. I just make it easier. And your maximum's at 100. If you ever change your maximum, make sure it's less, or I mean greater than your second pump that's going to start. Otherwise, we're never going to call a second pump. I don't foresee anything changing other than your desired levels and your stop levels. These are really the only 2 points that you're going to change. We do have ramping. It's to kind of prevent the pump from drastically changing. It's supposed to be 1.5% per second. And here's finally your order. If you were to put in a value of 123, that's going to mean your lead pump is 1, your second pump is 2, your third pump is 3. That's going to be a fixed order. It's not going to rotate. If you leave a 0 in here, then it's going to rotate. It's going to function, like you guys are used to. If you have currently pump 1 running and you go from 0 to 1, 2, 3, nothing will happen. But if you go pump 1's the only pump running and I change my order to 2, 3, 1, pump 1 is going to stop right there and pump 2 is going to start. If you do have a fixed order and the first pump is not available, then you will go to the second pump automatically. But when that first pump does become available, we'll stop and start the other at the same time. Any questions on the controls for PLC 1? Your PID page, this is where we would set up our PID. Currently we don't have a manual PID, so that situation that happened at Philadelphia won't happen here. I'm going to talk with Mike. We may add that manual PID, and that would basically force the PID to stop calculating. Sometimes you guys, Mike explained it, you want to run the pumps and continue to run them down. What you can do is you can put the pumps in manual and you can run and adjust the manual speed, and that'll prevent that. What will stop a pump from running is the low alarm. So if you're going to run it below what we have the low there because the pump manufacturer, that's the setting that they have. But if I know sometimes you do scouring, you want to run it a lot lower than what the stop set point is, that's how you would be able to drain, is to put it that way and still be protected when you reach the low level. If you put it in hand, you're not protected anymore from a low level. Hand at the VFD, the HOA hand. We have a level differential. I do notice that we're a lot more sensitive at Montclair to a difference between the levels. I don't know if there's rags that come and float on the top or something like that, but we do tend to pick up a difference. I know when we start and stop, sometimes the A level will be higher, and then other times the B level will be higher. I wish I could find a pattern to tell you how it does it, but it really does change. I don't know if, like I said, if there's something floating. These alarms, we could increase them if they become nuisance. If you're constantly seeing these at SCADA, we could either increase the delay or we could increase the difference of the level. But what that looks at is if in this case one level is 4.96, the other is 4.89. The difference between them is less than, is 0.07, so neither of these alarms would be triggered. If this was 5.96, then we'd be a whole foot away, and then both these alarms would be triggered. What that's really trying to do is tell you there's probably something wrong with one of the levels, and that's what the purpose of that is. But again, if you're getting too many of them, we can change that level the difference or the delay. We also have PLC 2 not active. So if PLC 2 is not active, that means it's not running in the background. It's not going to back you up if something happens to PLC 1. Then you have your PLC 2 is in control. That means PLC 1 has stopped running and it's now PLC 2 is in control. It's taking control of all the pumps. Keep in mind with PLC 1 you actually have 2 processors there. So if one faulted, for whatever reason, the second would take over. You wouldn't notice. It would be seamless. You would get an alarm or a status back at SCADA, but you wouldn't actually stop running PLC 1. If you lost power in the whole cabinet, that's a different story. Now both processors, and that's why PLC 2 is there. Down here is our PID, the controls that we have. I don't use any of the alarms or anything like that. The biggest screen we get to is, let's see, this one, which would be, so your maintenance in the 3rd tab. This is page 22. Here's your proportional, integral, and derivative. Unless you really understand them, I can give you a quick summary, but have somebody that does. Your proportional says, I am this far away, so I'm going to make this change. Think of it as you're driving a car, you're trying to get to 55, but you've got so many tickets from the police, you can't speed at all. So you're going to slam on the gas and get up to 55, but as you kind of get closer, you're letting off on the gas. That's kind of your integral. You're like, I don't want to overshoot. And then your Z is kind of another correction on that, or your D, your derivative. So that's kind of how a PID works. You go up a hill, all of a sudden you realize you got to press a little gas, and then when you go down, you got to let off because you're trying to maintain. Your cruise control works this way. Our pumps work this way. We've been pretty consistent, so there shouldn't be any need to change this, but if ever you do, this would be where you would make it. Okay, there's a lot of, again, I displayed all the screens for you, but that was the big one. If there's ever any question that you have on that, that would, again, your help menu, this is available on every object. Here's your HVAC screen. We're on page 26 now. So we still have our temperature in our cabinet. We have our exhaust fan, whether it's running or not running. And then we have the main system. The main system has 2 AC units, and each AC unit has a supply and return damper. These should be white for open, dark gray for closed. We did not have it installed, so it thinks it's moving. Somewhere in transition. We don't have the auto on any of these 3, so that's why there's an interlock associated. When you pop open these, though, we don't actually, it doesn't show the interlock because there's no controls. All you can get to is the runtime. It's not a great thing, but I can't do anything about it. This is a Rockwell issue. But just realize that looking at this screen, you do see that there's something wrong with the device itself. Okay. We do have, if the exhaust fan, there's an alarm. If it's not running, we don't have the not running, but there is both of those units, they have alarms associated with it. So you would be able to see if you have a failure with one of the 2 units, not just that it's powered off. Our gas monitoring is really simple. It's just a blown up view of the 3 gas things that we're monitoring. Your miscellaneous alarm, this is where I was talking about. There's lots of power supplies in there. We have 3 racks. We have our primary PLC, our secondary, and then the actual I/O. Each one of those racks has 2 power supplies associated with it. That way, if anything happens to a single power supply, nothing happens to your system. If the rack 1A, if both power supplies went out, rack 1B, which is the second processor, would take over. Seamlessly, you wouldn't notice it. Your I/O rack, if you did lose both power supplies, then you do have a problem because you can't go in or out. So all your VFDs would be off, all your statuses would be off, you wouldn't look at any levels. That would be a major fault. We do have DC power. We use that for reference for a lot of things, and also controlling equipment, usually comm equipment within there. Finally, we have our intrusion alarm, and as you can see, we actually have an intrusion right now because that's what that little alarm bell is. Your alarm delays, these are all in seconds. If you remember back in the analogs, all you could set was the actual level that triggered the high, not what the delay or how long it has to be true. So that's what these delays is. It's a way to get to it. Finally, we get to the site page. There's a little paragraph. Hopefully it summarizes and accurately what the site does. There's a generator status. We have ATS in normal, ATS in emergency, and then we have the remaining alarms dealing with comm and the power. I also have the HMI shutdown on this page. When you press it, there's a big pop-up. You know, it doesn't actually shut down. You can still press the cancel button. If you do still press the yes, I want to shut down the HMI, the way to get it back is just to hit the run the program. I realized that I shouldn't have had such an instant thing, and I'll have that same thing done at Philadelphia so that we don't shut down by accident by pushing that extra button. Finally, this is the power monitor. I kind of left it in development mode, so that's why all these are N's. They're actually numbers, but you can see here's your gas detected, here's your high level, and here's what it looks like if PLC 2 is in control. That's, it's no longer blue, it's a big red symbol that says, hey, something's wrong with this PLC 2. And this is going to be, these three are going to be on every page that you're at. And then finally we have our alarms. This is a summary of all alarms. This is acknowledge and acknowledge all. This is only for this page. It's not to clear SCADA alarms. It's not to reset any alarms in the PLC. But when you press them, if the alarm has gone away, they'll disappear from this list. But if a lot of times you'll come up, I don't know if you've seen the alarm pop up, and it's blank. You knew you had an alarm, but you don't know what it was. If you go to this page, it'll show, and there's an indication that it's actually disappeared, returned to normal. Okay, PLC 2. I was not able to take live status, so you get developmental. So you actually get to see everything that's on here. PLC 2 is a lot smaller display, so when we try to do a pop-up, the pop-up doesn't fit on PLC 2's display. So we actually go to another screen. But we have our 3 pumps. It goes 1, then 2, then 3. We have our level, and then we have return to normal. So normally this white text is normal operation, and you don't see this button. If PLC 2 takes over, it'll say backup control enabled. It's in red, and this button is active. That means PLC 2. So to be able to return back to control, you have to go to PLC 2 and press this button. You're not able to do it from SCADA. We want you to come on site. We want you to investigate. The site's still functioning. It's still running with PLC 2. You've got enough time to get out there. It can run 3 pumps. So when we press the pump screen, this is what pops up. So we have our power timer, basically when a PLC restarts or we switch from emergency to normal or normal to emergency, there's a small delay to kind of make sure that the levels are in accurately. We have the ready signal coming in. We have a generator restriction. We talked about that. If 2 pumps are running, doesn't matter if the VFD's on in hand and running or if it's called from the PLC. This will be, if 2 of them are running, the 3rd one will be not ready. Now, if you are on generator, the PLC is running 2, and you try to start the 3rd, the moment it gets running, if it can't, we're pretty sure it can because they're VFDs, the other 2 pumps are going to stop. And then one's going to restart after 3 minutes. And that's because both of these suddenly see 3 pumps running, and they're both going to stop. So keep in mind, if you want to try to run 3 pumps on the generator, you're going to have to run them all 3 in hand to be able to get that. Not just the 3rd pump, because you're going to drop the other 2. It's not recommended, but when Joe was out there, he was like, give me more. We were running 2 pumps at 100%. And he said there was probably more than enough power available for a 3rd to start. We've got our lows. If there's an alarm, you just hit here's our reset. Here's our operator mode versus program mode, just like on the pop-up, and here's our start and stop. We don't have a speed setting because that's when you run it, it runs at 55 Hertz. And then here's your status. Here's your operator mode that's active, and then here's a hand. This normally says program. When you press the level, it actually pops to this one where you have, here's all your set points for the level, here's your delays, and then here's level 1 versus 2. It does not have a differential level alarm. At the bottom we have set points 1 and 2 that you could press. Set point 1, and we actually start based on level, not based on pump speed at PLC 2. The spec called for everything to be starting based on the high level. I thought it was kind of unnecessary to trigger an alarm if you're running at PLC 2. So I do have separate set points for these. You can set them to the high level, and they would start based on that. The second one is, again, your 3 minutes between starts, and then what level is it going to take over? So we have it at 6.4, which is your high level, or 6.2, just below that, so that we can try to take over. We did try once we were up and running and trying to start at a higher level than what we currently have. It's very close to not recovering at a peak time. We get 1 pump started, we get 2 pump, but that level just kept rising. So be careful raising the start level as well back at PLC 1. And then here's your alarm screens. We monitor the UPS status, and then we have main PLC, both COM and the digital signal, and then finally a SCADA COM fail. Okay, I'm just going to ask, because I think I've covered most of these. Do we have questions about how they start at PLC 1? The pump start, the sequence it goes through? Again, the lead always starts on level, either PLC, and then it just ramps up. When it gets to a high enough speed, it'll start. If it's at that speed but it's below the desired, then we're like, well, it's got control, we're not going to run the timer. That way we don't start the second pump unnecessarily. We're going to wait for it to get above the desired. And then the lag 2 actually has a second level that's really high, higher, to just prevent 3 pumps from running. Give 2 pumps a chance. PLC 2 takes over at that takeover, as well as PLC 1 failing. So what happens? A PLC, we start at the add speed. We run there for about 10 seconds, and then we let the PID take control. That allows the pump to ramp and the PID not to really overshoot, because the pump hasn't started running yet. At PLC 2, all pumps were run. The biggest thing is, why did it stop? The most normal is because we ramped down our speed, and the lag 1 and lag 2, they're not needed anymore. We only need 1 pump, or we only need 2 instead of 3. Or we've actually reached our low level, our stop level for the lead pump. Keep in mind, if the lead pump says to stop, we'll stop all pumps. So if our PID didn't react fast enough, or you extended the time, and we're running at min speed, and we ramped all the way down to that lead stop set point, we're going to stop all pumps at that point. We don't want to run to a low. If the HOA is not an auto, that's a instant stop at the PLC. That's not a, we'll go to the backup. There's no ramping to that. If we triggered a low alarm, that means the highest level is low, then we're going to stop all pumps. So if you run it in hand, even or in operator mode, let me get my, through the PLC, you're still protected with your low level. You had a level signal failure, meaning that not just one, but both levels have failed. When you recover from power, you'll actually see that the levels go to weird numbers. Or we had a power outage, or the VFD itself faulted. The VFD will fault on high pressure and high temperature, or anything that the VFD monitors itself. I believe it may also be protected wire-wise on the leak detection, but the PLC will continue to run even if there's a moisture leak. And then why did PLC 1 take over? We've talked about the level. We've also talked about PLC 1 failing. We haven't talked about how do I get it back besides just pressing that button. Number one, PLC 1 needs to be back up and running, or it's not going to work. You can press that button all you want. Number two, you have to be below your takeover set point. If your takeover set point is 6.2 feet and you're at 6.4, you're not going to allow, you're not going to switch over to 1, because your level's not low enough. So if you forced PLC 2 to take control, which we did, and we put in a value of 4 until we changed that set point back to 6, we weren't allowed to take over. That's how we tested it. If you ever want to test controls through PLC 2, that's what I would do, is I would just change your takeover set point to a really low value. PLC 2 will take over. Again, other than occasional maintenance, I would also not do that at a peak time, just because to get two pumps running, it sweats you. Okay, there are 2 levels. Again, that's for the redundancy. There's 2 levels at PLC 1, 2 levels at PLC 2. I'm not sure what SCADA is going to display for you, if they display all 4 levels or they only display the 1 level. I think for now it's only going to be the 1 single level, but once you get updated to the new system, it might actually display 4 levels, and that might be, basically it's going to be the highest level of that we're looking at. How does the HVAC operate? Like I said, it's just like normal air conditioning. You go up, you change your start. The Christian Brothers will give you training on that. That's not even Tesco supplies. I believe it's Christian. How do I clear alarms? There's at the bottom right of every alarm, there's an alarm reset. You can also specifically do it, if you don't want to globally clear everything and you only want to clear pump 1 alarms, open up pump 1, press that ACK button. Or open up the level, press the level ACK button. It'll either clear individually, or if you do the ACK all, try to clear them all. Any questions? That's the operation of Montclair. This is the topic from last time. A lot of you have questions on why are we changing to this system of white pumps running. I like the old green and red. The idea is so that you would be able to to look, they call it high performance graphics. They want to, if you just look at a system, they want to point out any errors first, then you're going to look at anything that's normal. So that's the idea behind, they want to try to keep away, kind of keep it bland except for alarms. It's also, this is kind of, there is a Rockwell generated that they've done support. So this all comes directly from Allen Bradley, all the colors, everything. When you do SCADA, I believe either this summer they're going to start or next summer, all your graphics for all your sites are going to kind of look like this. So Philadelphia, Montclair are your guinea pigs. We went over the help with the symbols, and like I said, the biggest ones are your H. It's a yellow H, a blue O, or the alarm bell, or that gray stop sign. If you see any of those, that's telling you something's abnormal. Otherwise, if you don't see anything, you're good. Okay, and again, the biggest, I think you called it hand and auto right now at SCADA. That you put in hand and you're able to control the pump that you like from SCADA. That's now called operator mode. And then if you put it in auto where it runs on a PID, that's the program mode. That's really the biggest terminology change. Everything else is pretty much the similar. Are there any final questions?
Can we change that back to hand and auto?
Honestly, that would be something that we'd have to discuss with Rockwell how to do that. Just because their symbols for the operator mode is a blue O, I would have to change that in their base. Yeah. We may be able to change the text of that, or we may be able to put something to the side that says what it is. But it's Rockwell's attempt to differentiate between your HOA auto, and your HOA hand. That's what they consider hand, is you going out to the VFD and putting it in hand. Now the PLC has no control. That's why they like to do hand and auto, is at that point. And then there's a difference when you go back to PLC control. Now you have all different modes. That's the reason behind it, and that's why it's called that way. I know some sites, the HOA is actually a LOR, local off remote.
What does the display look like when somebody goes to the motor control and put it in local?
That would be the yellow H. I think I had that on one of them. Right around this little symbol this P would have a yellow H instead. And that would be what it would be, a yellow H with a black text. Typically, even the program mode, it doesn't show up. So if you see nothing, you're good. If you see any color that's up there, other than a blue running, the pump running in blue, and the text say stopping, then you're normal. Okay, time to wake up. It's like